Rational exponents. Whenever I see the word rational, I think about fractions. And what we're going to talk about today is about exponents that are fractions. But before we work with that, I'm going to show you an example, just a little demonstration on how we can go from radicals to expressions with fractional exponents or rational exponents. Let's say I have the cubed root of 8 squared, and I ask you to tell me how much this is. This is what you would do. You would say, well, the cubed root of 8 squared is the same thing as the cubed root of 64 because 8 squared is 64. And then you can think about a number that you multiply by that same number 3 times because my root is 3 and get 64, and that number is 4. 4 times 4 times 4 is 64. Okay? Now if I take this other expression, 8 to the 2/3 power. And notice my exponent here is a fraction. If I take this fraction with this expression and I rewrite it, I can rewrite 8. I can rewrite 8 as 2 to the 3rd power. Yes? Right? I take 8, I write it as 2 to the 3rd power, and I keep this exponent. So what I've done is just rewrite 8, and I kept my original exponent, which is a fraction. And notice that now I have a power raised to a power. Now remember from your law of exponents, whenever you have a power raised to another power, what you need to do is you multiply the powers. That gives you x to the 6th power. So that's what we're going to do here. We multiply the powers. That's going to give you 2 to the 3rd times 2/3 power. You multiply. And when you multiply fractions, remember, you multiply numerator times numerator and denominator times denominator, and the denominator here for 3 is 1. 1 times 3, 3. And that gives you 6/3. Okay? So this gives you 2 to the 6/3 power. And that is equivalent to 2 to the 2nd power because 6/3 is 2, and that gives you 4. Now, very important result here. Notice, this expression is equal to 4. This expression is equal to 4. So that means if this is equal to that, and this is equal to that, then this has to be equal to this. This is the transitive property that you learned in algebra. If A is equal to B and B is equal to C, then A has to equal C. So with these results, that means that this and this are equal. I can say that the cubed root of 8 squared is the same thing as 8 raised to the 2/3 power. And we have found a way to change a radical expression into an expression with a rational exponent. And look at what happens. This is how you do that. Your radicand is 8. Your exponent of your radicand is 2, and that 2 becomes the numerator of your rational exponent, and the index or your root becomes your denominator of your exponent. Okay? Very simple. And that's how you switch from one form to the other. Now, another thing I want to state formally is the definition of rational exponents. And this is stated as whenever you have C raised to a fraction t/k, this is going to be equivalent to c to the t power and the kth root, and that is also equivalent to having everything raised to the t power. Okay? Now let's do this in numbers, because I know with letters it's not easy to understand. Okay? This is what it means. If I have, let's take this same example, 8 raised to the 2/3 power, that is going to be equivalent to having the denominator be your root, the radicand will be your 8, your base, and the 2 in the numerator is your exponent. That's what this means. But it also says that this is equivalent. You can have the cube root of 8 squared, or you could have the cube root of 8 everything squared. That is equivalent, okay? Because if you take the cube root of 8 squared, that's the same thing as the cube root of 64, which is 4. If you take the cube root of 8, that gives you 2, and 2 squared is 4. So either way, raising the whole radical to the second power or just raising the radicand to the second power, it's going to give you the same thing. Okay, so this is the formal definition of the rational exponents, okay? And there you have it. Let's do one more example on how to switch. Let's say I ask you to write this as a rational exponent. What you do here is you take 4. Remember, your exponent becomes the numerator of your rational exponent, and the denominator of your rational exponent is the index or the root. In this case, there's nothing written here, so that must mean it's a square root, so it's a 2. And you can go ahead and say, well, this is 4 to the 3rd power, which is 64. Okay? If I ask you to change this expression, let's say x, well, this is x, your exponent is 7, your denominator 3. And that's how you rewrite that. I can also give you a rational exponent. Let's say 24 raised to the 1/4 power. And to write that as a radical, 24, your numerator is the exponent. This is an exponent of 1, so we don't write it. And your root is 4, so this is the 4th root of 24. Okay? And that's how you switch from radicals to exponential fractions or rational exponents, and from a rational exponent expression to a radical. I'll see you in the next video.